Welcome back, guys. My name is DrAvitech, and in this video, I'm going to be solving these advanced problems in beta and gamma function. So let's get started with the first one. Let me see them clearly. Now, remember to hit the subscribe button, like this very video, and share it across to your course mates. Okay, I kind of think that for question 1, there's a better way to solve it. I have a long process and I have a short one. Let me start with the short one. But the short one, I only kind of saw it somewhere else. What I actually know is how to use the long method. But let's go with the short one. So let me start with the first one. Okay, so the first one says integral from 0 to 1 of s cubed ln 3x dx. Okay, now as you can see, this doesn't look quite like either beta or gamma. It doesn't. But I know that if I should have ln, I could actually bring in an e. They kind of go hand in hand, they kind of go hand in hand. And this can be rewritten as integral from 0 to 1 of s cubed ln x, everything to the power of 3. It's the same thing, basically. It's the same thing. And then dx. So you can see that this is actually looking much more beautiful, much more beautiful. So anytime I see ln, there's an e somewhere. There's just the natural, that e is going to be there. So the solution I'm going to use is, I'm going to say let x be equal e to the power of minus t. To start with, this doesn't even have an e. Remember the standard way of writing gamma function. There should be an exponential to the power of negative something. So let us just say, okay, I like using u. So let me just call it u. Yeah, let me call it u. Let me not call it c. So x is equal e to the power of negative u. So I'm following the shorter process, the shorter one. Now, if x is equal to negative u, you do agree that we have to differentiate, right? Okay, so dx is equal, when you differentiate this, what would you have? You're going to have minus e, so minus u du. That's what you're basically going to have when you differentiate that. Now, what is the next thing we can do? We need to find out what our limit is going to become. So what will be the new value for our limit? What's going to be the new value for our limit? Now, if s is equal e to the minus u, I want to make you the subject. Yeah, I want to make you the subject. It's much more better that way. Though, I can still solve this question without making you the subject. But let me just make you the subject. Okay. At x equal to 1, I don't want to make you the subject, but let's just see. At s equal to 1, so when the upper limit is 1, we know that x is equal e to negative u. Now x is 1, so 1 is equal e to negative u. And what do you think u is going to be? Definitely, you remember that anything raised to the power of 0, or when a number is raised to the power of 0, that number is going to give you 1. So it means u has to be 0. Because e to the power of minus 0 will give us 1. So this means u is equal to what? 0. Now, if I had made this way the formula, I'm going to be having ln of 1. And ln of 1 is basically this guy. So the natural logarithm of 1 is just 0. Now, the next one is at x equal to 0. We cannot have x equal to e to negative u. So x is 0 equal e to negative u. Now here's the thing. If I had made you the subject, I would just take the ln of both sides. And ln of 0 would be approaching infinity. But here's another way to do this. I've kind of done this before. Yeah, I've kind of done this before. So this is u, which we have, u. I'm going to say that if e is raised to the power of minus infinity, I've kind of done this before, so that's why it will be looking kind of different to you. But another way to do this is to say ln of this guy 0 is equal to ln of e to negative u. And ln of this would give us, this should be negative infinity. And then this would give us minus u. So when the minus takes care of the minus, we're then going to be having it that u is equal to infinity. Now, so this is what we have. The next thing I'm going to do is to put in these values back into our expression. Okay. Let's see. So I think I can use this tiny space. So we have the integral from 0 to 1, but now when s was 0, we had infinity. So this would be infinity down to when x was 1, u was 0. Now this is x, but remember that x is now e to negative u. That's what x is, e to negative u. So this is e to negative u, but everything is being cubed. So I could just say everything here is raised to the power of 3. Now this is ln. X is e to the minus u. So we're going to have e to minus u. And this is all raised to the power of 3. dx is minus e to minus u. I think I'm just going to come here. Three ln e to negative u cubed. Then dx is minus e to minus u du. Okay, I think that's actually much more better. That's much more better. So, what do I notice? First of all, I can bring out this minus. I can bring out the minus. So this is minus integral from infinity to 0. Now, if I do this, take a look at this. We have e to minus u to the power of 3. And this is e to the minus u to the power of 1. Altogether, both of them will be giving us e to negative u all to the power of 4. You know, they're kind of the same thing. So if you're multiplying two same things in indices, you kind of add up the powers. So that will give us to the power of 4. Now, this and this are two opposite operations. They are two opposite operations. So what we're going to be left with is going to become minus u. That's what we're going to be left with. Minus u. That's what we're going to be left with. So this is minus u to the power of 3. Look at it this way. Ln e is just 1. Because ln is natural logarithm to the base of e. So if ln means this and then you have e, log e is 1. So this is just 1 here, and then we have minus u. And what will be left here becomes du. Okay, now, let's proceed. This is a cube. If you should cube minus, you're also going to have minus u cubed. So let that minus come and meet this minus. That becomes a plus. So this is integral from infinity to 0 of, this is u cubed. Then this is e to negative 4u du. Yeah, it's now looking like our gamma. Kind of looking like our gamma now. Let me explain that step again. Minus u cubed. If you should expand this, you're going to have minus u cubed. So that minus will make this minus to become a plus. And then I wrote the u cubed first because there's no minus anymore. I've used it to multiply this. And then this minus u times 4, that's minus 4u. And then du. Beautiful. Okay. Now, you know, this is still kind of not looking fine in a way. It's still not looking fine. Because on a normal day, the standard way of writing gamma, the infinity has to be the upper limit, the 0 has to be the lower limit. Then secondly, our exponential is always raised to a single variable. So this is 4u. What should be here has to just be u, or has to just be another alphabet totally. Now, believe me when I tell you this is actually a shorter approach. Okay, so what I'm going to do is to say, the only way for me to flip my interval, flip it, is to negate the integral. So if I should put a minus, this is going to flip. So this is 0 to infinity. Then I have u cubed, e to negative 4u du. Now again, we need another substitution. So let k, I want to use k. Yeah, let me use k. Let k equal to 4u. Now if k is equal to 4u, when I differentiate, the k is going to become 4 du. Then to make du the subject, I need to divide by 4. So this is over 4, this is over 4. So that means du is equal to k over 4. So this is what we have. Now, what else is left? We need to make u the subject, because as you can see, this is u here. We need to make u the subject. So how do we make u the subject? From this expression, k over 4 is equal to u, because we have to divide by 4. We have to divide by 4. So our integral will then become minus integral from 0 to infinity. The limit will not change in this case, because 4 times infinity is still infinity, 4 times 0 is still 0. So this is u, and u is k over 4. So this is k over 4. Every single thing here is raised to the power of 3. Then this is e to negative 4u is k. And then what is du? Du is dk over 4. So dk over 4. Okay, so let's expand this. We're almost there. So this is minus integral from 0 to infinity, k cubed divided by 4 cubed is 64, e to negative k dk over 4. Now, since these two guys are both denominators, I can bring it outside. So this is minus 1 over 128. Hold on. 256. 256. Because 64 times 4 is 256. Then we have the integral from 0 to infinity of k cubed e to negative k dk. Okay, so this is minus 1 over 256. Now, if you look at this, this is now our gamma function. So this is k cubed. So this will become times 3 factorial. Remember, when you're dealing with gamma, that's what you're going to have. So 3 factorial. So this is minus 1 over 256 times 3 factorial is 6. Or you could say 3 times 2 times 1. So 3 times 2 times 1. So 2 here is 1. 2 into this is 128. So this is minus 1 times 3, that's 3 over 128. That looks like a lot. In fact, do you know that this is actually a standard form? You can be asked to prove something like this. You can be asked to prove that the integral from 0 to 1 of x ln x all to the power of 3, no, let me put n since it's a proof, n dx is equal to minus 1 all to the power of n factorial divided by n plus 1 factorial. Hold on, I'm trying to get it. N plus 1 factorial, because I think there should be a proof for this. Yeah, there has to be a proof for it. So we have n, then n plus 1 factorial. I kind of don't remember, but I know that there should be a kind of formula like this. So let me just leave that. But it kind of looks like that. I feel like something is missing at the denominator. Let's kind of proceed. I don't want to make this video too long because there's a lot of questions to solve. Question 2. So we have the integral from 0 to 1 of dx divided by the root of negative ln x. I feel like this has to be short. It has to be short. So what I'm going to do here is to call every single thing here. Every single thing here, let me call it to be u. So I'm going to say let u equal minus ln x. I just think it's better. So let u equal to minus ln x. Next, let me kind of start with my, what's it called? My differentiation. So if I should differentiate this, this would be du equal minus. Remember that if you should differentiate ln x, you will just have 1 over x. Remember, right? So dx. That's what you're going to get. Now, we're trying to make ds stand alone. So this x would have to come here. We kind of need to cross multiply. So when this x comes here, this will become x du equal to minus dx. But we need the minus to be here too, so put the minus here. Then this is dx. But since we're making a substitution, we try our best to make sure that x does not belong in this du portion. So since we know that u is equal to minus ln x, what am I going to do to make s the subject? So first of all, the minus can come here. So from this, the minus comes there. So that's minus u equal ln x. What's the next thing I'm going to do? Take the exponential e of both sides. So e of negative u is equal to x. That's just what it's going to become. E to negative u is equal to x from the properties of logarithms. So this way I'm going to just get. Okay. Should I explain that part again? You know, sometimes when I'm teaching, I feel like some part is not clear. Let me explain this again. Look. This is minus u equal to ln x. If I take the e of both sides, so this is e to negative u, and then e, and these are two opposite functions. So this will just be x. Another way to put this is to say if you have negative u equal ln x, another way to put this is minus u equal logarithm base of ex. Now remember that in logarithms back then, let me kind of rewrite this. In logarithms, the number x is always e to the power of this. So I believe I've been able to explain it, why that is that. Okay, so yeah, I'm going to wipe this out. All right, so let's proceed. Then what's left? What's remaining? Our limits. Yeah, let's see for our limits. So for the upper limit, x was going to be 1. So since our u is now equal to minus ln 1, what does that mean? U is now 0 because ln 1 is 0. Logarithm of 1 is 0 to any base. So the lower limit is x equal to 0. So this is u equal to minus ln 0. So u is equal minus. We know that ln 0 is actually minus infinity. I think, yeah, ln 0 is minus infinity. So u would just be infinity. So you see that that's actually easy. Now let's put all of these guys into our integral. So the 1, when it was 1, we had 0. Then when it was 0, we had infinity. And then, let me kind of do some things here. This is dx, right? I'm going to write it beside this part. So this will be 1 over root u, because minus ln x is now just u. It's just u. Then this dx, I'm going to write it here. So what is dx? Dx is minus x du. Yeah, minus x du. But we've been able to solve for x. So that means this expression here will become, it's going to become minus x is e to negative u and then du. Yeah, I think that's just what it's going to be. So this is times minus e to negative u du. That's just better. Okay, now looking at this, the minus can come outside obviously. So this minus can step out. But remember that if this minus steps out, the normal representation of gamma function, the infinity should be at the top. Now the only way to do this is if there's a minus. So this minus would help us do that. Let's just make use of this minus to flip the limit of the integral. So using this minus, this will become infinity and then 0. You kind of flip it with this very minus. Now, we know that this could be 1 over, the square root guy actually means u to the power of half. And then we have e, so negative u du. Okay. Ooh. Okay. So this is integral from 0 to infinity. Now, the u could go up. So when the u comes up, this will become u to the negative half, and then e to negative u du. That's what we're going to have. So finally, that's just my gamma function. That's just gamma function. Now, but since we have fractions in this case, we cannot use factorial. Instead, we're just going to use the gamma representation of it. So this will be gamma of minus half plus 1. Minus half plus 1. So this is the gamma of, everything here is just a half. When you add these fractions up, you're going to have a half. So what is gamma of half? That's root pi. And that's just the answer to that very equation. Remember to hit the subscribe button, like this video, and share it across to your classmates. Let us do number 3. Oh, that's number 3 looks like a lot. Okay. Integral from 0 to infinity of 3 So negative 4s squared dx. Okay, now when you look at this problem, the first thing you want to do is, there's no exponential, there's no lane, but I kind of know that I can use one of the properties to solve this problem. Yeah, I can use one of the properties. So I know that if I take E and then lane of some number U, my answer is still U. Take a look at this properly. We kind of did something like that here when I was explaining this. When you say E to a natural logarithm of U, the answer is going to be this very U you have here. So what I'm planning to do is, this expression is still going to be the same, but I want to write it in terms of E and ln. Because obviously, I need my ln to come outside. I need this E, this exponential guy, I need it to be out. So what I'm going to do is, I'm going to say, since we know this is correct, we can say this is the integral from 0 to infinity of E ln 3 to the power of minus 4s squared dx. That's a lot. Okay, but that's actually easier. It's making our problem easy, not difficult. It's making our problem easy. Okay, so this is equal to integral from 0 to infinity. From laws of logarithm, the minus 4s squared can come to the front. This minus 4s can come to the front. This is E to minus 4s squared. You now cannot get the point, right? E to minus something. So E to the power of minus 4s squared ln 3 and then dx. That looks like a lot. So let's do this. Let's do it. Now this is E to the power of minus something. So what I'm going to say is, I don't want this is too bulky. So I'm going to say let U equal to 4s squared ln 3. Now if U is equal to 4s squared ln 3, I can differentiate this. Oh, this is a lot. Let me first of all make S the subject. So we have U, I need to divide by ln 3 equal to 4s squared. Okay, I can even divide by 4 ln 3. Yeah, divide by 4 ln 3. So we just have s squared, because 4 and ln 3 are constants. Now to remove this very square, I need to square root this side. So the square root of U divided by 4 ln 3 will give me x. Yep. This can be written in a better way, though. You could say this is root U divided by 2 root of ln 3. Yeah, that's just another way to write it. Yeah, that's another way to write it. Then, another thing is, if U is equal to 4s squared ln 3, I can say that du, when I differentiate 4s, what would you get? You're going to be having 8x. So this is 8x ln 3 du. Is there space? Hold on. 8x ln 3 du. Oh, dx. That's the x part. dx. Now what I'm going to do next is, I'm trying to make the s stand alone, because when I'm solving this, I want to remove this dx. I want to remove the dx. So I want to make the ds to stand alone. So what I have to do is to divide both sides by 8x ln 3. So we're going to have du divided by 8x ln 3 equal to dx. But again, remember that when you're doing this x should not be here. This x guy should not be here. So remember that we said s should equal this. X is going to equal this. So let's make that substitution. I'm trying to manage too much. So this is 8 root u divided by 2 root of ln 3. And then ln 3 equal to dx. I think I need to wipe a part of this board, otherwise I might start mixing things up. Remember to hit the subscribe button, like this video, and share it across to your classmates. My name is Dr. AVITECH. Okay. I want to wipe this part too, so I know I have some spaces. Okay, that's what do we have? Okay, let's see. This is a lot. Let's see how we can simplify this. Okay. So first of all, the 8 and the 2 will give me a 4. So that's looking fine in my eyes. So I'm going to be having dx equal to, okay, these two things are actually dividing, hope you know, because this is a quotient. So this can go to the top. This can go to the top. So we're going to have root of length 3 at the top. Okay. And du would also be there. Divided by 8 over 2, that's 4. And then I have my root u. And then length 3. Okay. Now, I'm kind of not yet done with simplifying this whole stuff. I'm not yet done. But the thing is, this is dx equal to this length 3 and this length 3, they can actually take care of themselves. Here's what's going to happen. I'm going to say this is root of length 3, so you know what I have just done. 4u to the power of half. Now this length 3 here, do you know that it's actually same thing as root of length 3 times root of length 3? It's the same thing. Because when two roots multiply, you just have the number inside. So it's the same thing. So one part of this will cancel one part of this. So this means that dx is du divided by 4u to the power of half root of length 3. Let's proceed. Okay. Okay, we can now put in everything here. Our limit will not change. I believe you know why. When you put in, where's this guy? 4s squared. When you put your x as infinity here, every single thing here is still infinity. When you put in 0, everything is still 0. So nothing changes. So our integral is going to equal integral from 0 to infinity. Yeah, we're using this guy, remember? 0 to infinity. Then this will be e. So negative, every single thing here was called u. So u, then dx. But dx is this whole bunch of stuff. This is what dx is. So dx is du divided by 4u to the power of half, and then root of length 3. Now you would actually kind of start appreciating what's going on because it will look much more easy. I promise you. So take the 4 outside, take the root of length 3 outside. So this means I'm going to be having 1 over 4 root length 3. And then we have the integral from 0 to infinity. Now this is u to the power of half, right? And it's at the denominator. So it can come on top. It can come on top. When it comes on top, it becomes u to negative half. That's what it becomes, u to negative half. And then we have e to negative u du. Yeah, I believe I didn't miss anything. Let me see. Yeah, I believe I did not miss anything. So right now, this actually looks like this. Yeah, so that's just root pi. It's just the same. This is just root pi. So this means that my answer becomes 1 over 4 root length 3 pi. I think I have to step back to take a look at this. The answer of this is looking weird. Let me see. Hold on. I kind of spotted a mistake. This should be roots. Yeah, I was like, it's kind of looking weird. That has to be roots because this was root pi. I only wrote that guy. So the answer for this can best be written as 1 over 4 root pi over length 3. Yeah, so that becomes the answer to that very equation. Yeah, that's all we have. Because this pi has a square root, length 3 also has a square root, and they are both dividing. So that will be the answer. Okay, number 4. Number 4 is actually easy. I feel like I shouldn't even do it, but let me just do it. So number 4, the integral from 0 to 4 of u to the 3 over 2 into 4 minus u to the power of 5 over 2 du. Yeah. Okay. Now, ideally, remember that the problem here is from beta, because this is beta. You know, sometimes you just have to look at it and see that it's beta. This guy here, this bracket should be 1 minus u and not 4 minus u. Now, since it's 4 minus, we need to divide by 4, because it is only when we say 4 over 4, that is when we kind of have our answer. So this will become the integral from 0 to 4, u to the 3 over 2, into 4 over 4 minus u over 4 to the power of 5 over 2 du. But there's a problem. There's a problem. The initial equation does not have a division by 4. You by your own self introduced the division by 4. You introduced it. So what do you expect? What should you do? This expression is now unbalanced. So to balance this expression, you need to multiply by 4. Remember, in maths, in chemistry, you must balance your equations. So if you, whatever you do to one side, do to the other side. So two opposite things. You've divided by 4. The opposite of division is multiplication. So you need to multiply by 4. In fact, not just only multiply. You need to be very careful, because this thing here has a power. So this guy also needs that same power. In one of my questions, I kind of explained why it's like that. So you must also give that very 4 the same power. Otherwise, there's no way for this over 4 to work. So now it is balanced. So this is integral from 0 to 4. Okay, that's a constant. Okay, so this is u to the 3 over 2. Now what would this be? 4 to the power of 5 over 2. Remember that the term over 2 means square root, right? The term over 2 means square root. So what is square root of 4? That's 2. Now what is 2 to the power of 5? That's 32. That's 32. Remember that these are advanced problems, but that's actually easy. You could do that with your calculator if you wish. So that's 32. So this is times 32. And then 4 over 4 is 1 minus u over 4 to the power of 5 over 2 du. Okay, let me bring 32 outside. So this becomes 32 integral from 0 to 4 u to the 3 over 2 into 1 minus u over 4 and then 5 over 2 du. Now, at this point, what do we do? Now, what we're going to do is we're going to say, let this u over 4 become something else. Because definitely from beta, this shouldn't be a fraction. It should just be a single variable. So let x equal u over 4. So I'm kind of picking a new thing. So let s equal to u over 4. Now, if s is equal to u over 4, what does this tell us about u? This tells us that 4x is equal to u, because you need to kind of cross multiply. So when you cross multiply, I think I should come here. When you cross multiply 4 times x, that will give us 4x equal to what? U. Better and beautiful. Now, what would I do next? I can say that, let me look for the limits first of all. So at s equal to 4, that's the upper limit. At s equal to 4, okay, wait, this is with respect to u. Oh, sorry, this is with respect to u. So at u equal to 4, at u equal to 4, this means that x is actually u over 4. So this will become 4 over 4, which is 1. Then at u equal to 0, remember that the original function is actually with respect to u. We are the ones changing it to x. So we need to find the value of x at each limit. So when u is equal to 0, we know that s is u over 4. So that's 0 over 4, which is 0. Next, let us find our derivative. Let us find our derivative. So if s is equal to u over 4, can we differentiate this whole expression? Yes. This is 4x, right? So differentiate for us, what would you get? You're going to have 4 dx. Differentiate, what would you have? Du. Yep. I think that is all we need. Even if we need any other thing, I would come back to this. So back to our integral. 32, the limit will not change from 0 to 4 to 0 to 1. This is 0 to 1. U, what's the value for u? U is what? 4x. So this is 4x, all to the power of 3 over 2. Then 1 minus, what is u over 4? U over 4 is just x to the power of 5 over 2. Then what is du? Du is 4 dx. This is a lot. Okay, but don't worry, we're almost done. So this 4 can come outside to multiply this. So the 4 coming out, let me see, this is 5, this is 2, so that's 128. So this is 128, integral from 0 to 1. Now be very careful here. You could actually expand this to become 4 to the 3 over 2, x to the 3 over 2, into 1 minus x 5 over 2 dx. So this is 128. Then integral 0 to 1. What do you notice here? This is 4 to the 3 over 2, and anything over 2 means square root. So what is the square root of 4? Square root of 4 is 2. And what is 2 to the power of 3? That's 8. So this is 8. That's 8. X to the 3 over 2, 1 minus x, and then 5 over 2 dx. Now the 8 is a constant, bring it outside. 1 to 8, hold on, 7, 3, that's 1024. Yeah, 1024. And then integral from 0 to 1, x to the 3 over 2, 1 minus x to the 5 over 2 dx. Now as you can see, this is now looking like our standard beta function. X to the power of something, 1 minus s to the power of something. But remember that in beta, we're always adding 1. When it looks like this, we're always going to be adding 1. So this is 1024 beta of, what is 3 over 2 plus 1? That's 5 over 2. Then what is 5 over 2 plus 1? That's 7 over 2. These are advanced problems, so do not be surprised. So let us now write that in terms of gamma. So that's 124. And then we're going to be having the gamma of 5 over 2 times gamma of 7 over 2 divided by the gamma of 5 over 2 plus 7 over 2. That's a lot. Okay, so this is 1024 times, we can use the recurrence relation here. If this is the gamma of 5 over 2, first of all, what is 5 over 2 minus 1? That will be 3 over 2. So we're going to have 3 over 2 times, what is 3 over 2 minus 1? That's 1 over 2. So this will become 1 over 2 gamma 1 over 2 times, and this is 7 over 2. So what's 7 over 2 minus 1? That's 5 over 2. 5 over 2 minus 1, 3 over 2. 3 over 2 minus 1, I need to wipe that part of the board. So I need to wipe this guy. Ugh. Okay. And then 1 over 2 gamma 1 over 2 divided by, now this denominator here, 5 plus 7 is 12. 5 plus 7 is 12. Then 12 over 2, that's 6. So this is the gamma of 6. Gamma of 6. Okay, now let's multiply. Let's multiply. So for the top, 3 times 5 times 3, that should be 45. That should be 45. So this is 1024 times 45. Then gamma of half times gamma of half. Remember that gamma of half is actually the square root of pi. So what is the square root of pi times another square root of pi? That's just pi. Gamma of half is equal root pi. So if we were to kind of square both sides, we're just going to be having pi. So that's why this will be 45 pi divided by all of the 2's. This is 1, 2, 3, 4, 5. So that's 32 when you multiply. Divided by, now the gamma of 6 is 5 factorial. Gamma of 6 is 5 factorial. Okay, so this is 1024 times 45 pi divided by 5 factorial. Remember that this over 32 can come down. I think, let me just put it here. This 32 can just come down. Yeah, it can just come down. So let me bring it down. And then times 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. I'm trying to reduce this. Okay, so 5 here is 1. 5 into this will give me 9. Now hold on. There's a way I kind of simplify. Please take note. You can just use your calculator. You can just use your calculator. So let's see. I have 5. 5 plus 2. 7. 7 plus 2. Sorry, 7 plus 1. 8. 8. 4. So this will be 4 times 9 pi, which is 36 pi. I think I need to cross-check this. Well, it's kind of looking correct. 36 pi. Let me cross-check. Something is not right. Hold on. Oh, something is not right. This 3, I've not yet used this 3. Yeah, I forgot to use this very 3. Okay, so when I use this very 3, 3 here is 1. 3 into this is 3. This ought to be 3 pi. So which is then 12 pi. Yeah, that was why I had to cross-check. So this was the answer is going to be. So let's move on to the next one. Number 5. Remember to hit the subscribe button. And if this video has been of help, please like this video for the YouTube algorithm. Number 5. The integral from 0 to 3 of dx divided by root 3x minus s squared. Okay, that's actually a simple problem. So it's kind of looking like this one. So this will become the integral from 0 to 3 of dx divided by, do you know that s is common here, right? So this will be the square root of x bracket 3 minus x. If you factorize it, that's what you're going to be having. So this is the integral from 0 to 3 of dx. Now I could break the roots. So this becomes root x dot root 3 minus x. You can see that, right? So this is what it's going to be. Now, I know it's not yet looking like what you already know, but let's proceed. This is the integral from 0 to 3 dx. And then this x here is raised to the power of half. And then 3 minus x is also raised to the power of half. Now, I could bring these two guys to the numerator. I could bring them to the numerator. So when I do that, okay, I didn't rule that correctly. I'll do something else. So integral from 0 to 3 of, let me bring them to the top. This x will then become x raised to the power of minus half. Then this will become 3 minus x to the power of minus half dx. So you can see that now looks like our better guy. But again, remember that this 3 should not be here. The 3 should not be here. So we need a 1 there. And the only way for us to get 1 is to divide. That's the only way for us to divide by 3. So this will become integral from 0 to 3 x to the power of minus half. Then let's divide by 3. This will be 3 over 3 minus x over 3 to the power of minus half dx. But remember, you divided by 3 by your own will. There was no division by 3 in the equation, so you've kind of unbalanced it. For you to make it balanced, you need to multiply by 3 that you divided by. And also make sure that the power, because the rule that is, how do I put it? The rule affecting everything here needs to follow what you did. So since you divided a bracket that has minus half as its power, you need to multiply with the 3. So that same minus half. Yeah, you need to multiply by that same minus half. Okay, so let me bring out this 3 to the minus half. 3 to minus half. And then integral from 0 to 3, x to the minus half. So only this one is out. So x to the minus half. 3 over 3 is 1. So this is 1 minus x over 3 to the minus half dx. Okay, that's almost looking like what we need. But I need to say let u be equal to x over 3. Let u equal x over 3. So like I said, it's looking like this guy. Let u equal x over 3. So this then means that I could multiply by 3. I could just multiply this by 3. So this becomes 3u equal to x. Now if 3u is equal to x, this means that when I differentiate the 3u, what would you have? You're going to have 3 du equal to differentiate x, you're going to have dx. So that's what we have. Next, let us check our limits. So at x, because it's with respect to x, so at x equal to 3, what will be the value for u? And remember that u is x over 3. So when you put 3 over 3, that's going to be 1. Then at s equal to 0, u will then become 0 over 3, so that's 0. So that's what we have. And we cannot put in everything into our integral. So we are going to say this is 3 to the minus half integral from 0 to 1, because our limits will then change 0 to 1. And then x, what is x? S is 3u, x is 3u. So this is 3u, all to the power of minus half, and then 1 minus x over 3, that's u, to the power of minus half. Then what is dx? Dx is 3 du. Okay. Let us see. This will then become 3 to the minus half integral from 0 to 1. Now when you expand this, this will be 3 to minus half u to minus half 1 minus u to minus half 3 du. Now this, look at, this is a constant. Let me use another color for that. This is a constant, this is a constant, this is also a constant. So I want to bring all of them out. So this will be 3 to negative half, 3 to negative half, 3 to the power of 1. This one is just 3 to the power of 1. So I want to just bring them out. The one will be left is integral from 0 to 1, u to negative half, 1 minus u to negative half du. That's what I'm going to be having. Okay. Now, if you take a look at this, this is all, what's it called? This is all indices. So this will be 3 to minus half plus 1. Yeah, minus half plus 1. Then I have everything here. This is now my beta function. So I'm just going to write this is beta function. Now let me add 1 to this too. So minus half plus 1, that's half. Minus half plus 1 again, that's half. Now, what is the answer of this? The answer of this is just 0. Yeah. Minus half is minus 1. Minus 1 plus 1, that's 0. So 3 to the power of 0 is 1. So the answer of this is just this beta part. Now, how do we express this beta part? This will be the gamma of 1 over 2, gamma of 1 over 2, divided by gamma of 1 over 2 plus 1 over 2. Okay, remember to hit the subscribe button, like this video, and share it across to your course mates. Let's see. I'm trying to make this video as short as possible. I need to wipe all of these guys very fast. Okay. Uh, yeah, I'm still going to write this. Okay. So this will then become, let me see. Yeah, this right here is root pi. So that's root pi times root pi. Now, half plus half. Half plus half is 1. So the gamma of 1 is just 1. So we're just going to say over 1. So the final answer of this is pi. That's just the final answer. Because root pi times another root pi, that's just going to be pi. So let us solve number 6. Let me see number 6. Integral from 0 to 1, root of 1 minus x over x dx. Now I have to solve number 6. So I had to pick up a call. So I have to solve number 6. What would I do about number 6? Here's the thing. This would be the integral 0 to 1. I could say this is 1 minus x divided by x with a root. Like, kind of share the roots. Dx. The key thing is you identifying what you should do. Sometimes you just have to use your instincts to be like, this is how it looks like. Okay, so this is integral from 0 to 1, 1 minus x to the power of half divided by x to the power of half dx. Now, this x to the power of minus half, I can bring it to the top. So this becomes integral from 0 to 1, x to the power of minus half, because when it's coming to the top, the exponent becomes negative. And then this is 1 minus x to the power of half dx. So as you can see, this is actually very easy to solve. So this is my beta function. So I'm just going to say this is beta of, this is minus half. So add 1 to this. When you add 1 to this, you're going to have half. Now this is half here. When you add 1 to this half, you're going to be having 3 over 2. So writing this in terms of gamma, this would be the gamma of 1 over 2 dot gamma of 3 over 2 divided by the gamma of 1 over 2 plus 3 over 2. Okay, now what is the gamma of 1 over 2? This is a much more special value. So gamma of 1 over 2 is just root pi. So that's root of pi times. Now how do we find gamma of 3 over 2? First of all, what is 3 over 2 minus 1? 3 over 2 minus 1 is 1 over 2. So this will be 1 over 2, gamma of 1 over 2. Divided by 1 over 2 plus 3 over 2 is 2. Because 1 plus 3, that's 4. 4 over 2 is 2. So gamma of 2. Okay, so this becomes root pi times half of root pi again, divided by gamma of 2 is 1 factorial. Gamma of 2 is 1 factorial. So that guy is just gone. So this will just become half of pi, because root pi times root pi, that's just pi. So that's going to be half of pi. Okay, let's go to question 7. So we have the integral from 0 to 2, 4 minus x squared, 3 over 2 dx. Okay, so first things first, this is easy, but at the same time, somehow, because two things are happening. There should be no over 4. There should be no 4 here. So you ought to divide by 4. So I'm going to say this is the integral from 0 to 2, 4 over 4 minus s squared over 4, all to the power of 3 over 2 dx. But remember, if you divide by 4, you need to multiply by 4. And the 4 you're multiplying by should have the same power, 3 over 2. It's a must. Okay, so this will then become, I can bring this out actually. If this is 4, the over 2, this over 2 means square root. So what is square root of 4? That's 2. 2 to the power of 3 is 8. So I can bring that out. So this is 8, integral from 0 to 2. Then I'm going to be having 1 minus s squared over 4, 3 over 2 dx. Let me pick a new. Okay. So now, The next thing I'm going to do is I'm going to say let u become s squared over 4. Oh, I've not opened this. Okay, so let u equal s squared over 4. Okay, now if u is equal to s squared over 4, let me make s the subject. Let me make x the subject. So this will first of all become 4u is equal to s squared. Then I'm going to say the square root of 4u is equal to x. So this means I'm going to be having square root of 4 is 2. So this is 2 root u equal to x. So that's 2u to the power of half equal to x. Okay, next. If 4u is equal to s squared, 4u is equal to s squared, this means that I can say that differentiate both sides. So when I differentiate 4u, I'm going to be having 4 du. Differentiate s, I'm going to be having 2x, and then you put your dx. Okay, now to make the s stand alone, I need to divide by 2x. So this is 4 du divided by 2x. And then equal to dx. But remember, x, I'll cancel out, so I'll cancel out. But remember that x is actually 2u to the power of half. So this is 4 du divided by 2 times 2u to the power of half equal to dx. Now 2 times 2 is the same thing as 4, so that's gone. Then if this u comes to the top, this will become u to the power of minus half du equal to dx. And the next one we're going to check is our limit. So let's see our limits. Let's see our limits. So when x is 2, so at s equal to 2, what was our u? Now remember that, where did we make, what was this guy? Okay, this is u. So u is equal s squared over 4. So when s was 2, that means this will become 2 squared over 4, and 2 squared is 4. So 4 over 4 is 1. Then at s equal to 0, we know that u is s squared over 4. So 0 squared over 4 is same thing as 0. So that's what our limit has become. Okay, so let me go back into my integral and make my substitutions. So that's 8, integral from 0 to 1. Then 1 minus s squared over 4 is now u to the power of 3 over 2. Then dx, this is what dx is. dx is u to the power of minus half du. Beautiful, isn't it? So let me just bring this one to the front so it's, appears a certain way. This is 8 integral from 0 to 1, u to minus half, 1 minus u to the 3 over 2 du. And, oh no, that's, well, I wanted to say it almost looks the same, but it's not kind of almost the same. So this is 8 beta of, let me add 1 to this, because remember from the standard form, you need to add 1 to this. So minus half plus 1 is just half. Then 3 over 2 plus 1 is 5 over 2. So now let's evaluate that. This will be 8 gamma of 1 over 2, gamma of 5 over 2, divided by the gamma of 1 over 2 plus 5 over 2. So this is 8. Now, what is the gamma of half? That value is known. That's just root pi. Times what is the gamma of 5 over 2? You first of all have to start minusing 1. So 5 over 2 minus 1 is 3 over 2. 3 over 2 minus 1 is 1 over 2. And then gamma 1 over 2. Divided by gamma half plus 5 over 2 is just 3. Now how did I get 3? 1 plus 5, that's 6. 6 over 2 is 3. Okay. So what would I do? This becomes 8 times root pi times 3 over 4. This again is root pi because the gamma of half is root pi. Divided by gamma of 3 is just 2 factorial. It's just 2 factorial. So we're going to be having 8 times root pi is pi times this over 4. We'll come and make this 2 factorial. But remember that 2 factorial is what? 2 factorial is just 2. So if this 4 comes down to meet this very 2, we're going to be having everything over 8 with a 3. So this 8 will cancel out this 8. So the answer of this is 3 pi. Remember, you can just use your calculator to just get your answer directly. Now, always remember to hit the subscribe button, like this video, and share it across to your friends. The last question for today. I kind of think I might not solve this question. Like, I wanted to leave it for you guys to solve. Something is telling me to leave it for you guys. I think I might just state what you should do. 0 to e of x dx divided by root of 1 minus ln x. Yep. Okay. If I'm to solve this, the answer is kind of weird. The answer has, I think, e squared over root 2. It's kind of long in a way. So what I would do is to say, let everything here be equal to u. I don't think I want to solve this. I want you guys to try it out yourself. But if you want me to solve it, comment, solve it. So you're going to make two substitutions here. So the first one is to say, let u equal to 1 minus ln x. Then you put your limits. When you put in your limits, this will become u equal 1 minus ln e. Remember, this is ln e, right? So ln e is 1. So u will now become 1 minus 1. So u is now 0. Then, when you put in your lower limits, u will then become 1 minus ln 0. So that's 1 minus. But remember that ln 0 is minus infinity. Ln 0 is minus infinity. So that's minus infinity. So this is 1 plus infinity, which is just infinity. So you're going to have 0 and infinity. Then, just go through all of the processes. When you're done, you still have to, I can't really remember what you need to substitute again. So finally solve this problem. So I'm going to leave that one for you. Remember to hit the subscribe button, like this video, and share it across to your classmates. This will be all for now. Let us proceed to some other interesting topics in advanced engineering mathematics.